everyone, and welcome back to TAL, also known as Teach As We Learn. Today I'm going to be teaching you about domain and range, so let's begin. So in simple and non-fancy words, domain and range are just X and Y values. There you go. That's literally it. Domain is X values and range is Y values. And a way to remember that domain is particularly only X values and range is particularly only Y values, we can remember it by an abbreviation called doctor. D in doctor is always first, and that's similarly with X. X values are always first, and range is Y values. So doctor is a simple abbreviation which you can use to remember domain is X and range is Y. So if we see an example here, if I draw a little table. So X, Y. So I have 1, 5, 2, 10, 3, 15. So our domain would have been 1, 2, and 3. And our range would have been our Y values, which would have been 5, 10, and 15. This is basically what we call discrete domain and range. Discrete is basically tables, charts, basically a chart where points will be like scattered and not connected. The reason that this is called discrete domain is because they aren't connected in a line like this, or they aren't connected together like that. They are far off from each other, right? They're not connected. They're one here. Yes, they're near maybe each other, more near here, but they're still not connected. So the discrete domain and range is not connected. Then we have continuous domain and range, and continuous domain and range looks like this. Basically, they're connected. So there's seen a line here, it's connected. This V over here, it's connected. Basically, continuous is connected, and you can remember it by C for continuous and C for connected. So over here, we have a graph, and we basically have learned the domain and range, how to find with discrete domain and range, right? We have, we find it from charts. We were just, okay, whatever X is, that's your domain. Whatever Y is, that's your range. But it does not work like that for continuous. Continuous is a little different because we find domain and range a little different. So if we remember, domain, this yellow, is our X, and range is our. So we have that, I guess, registered in our brain. Domain is X, range is Y. Remember doctor, X goes first, just like D goes first in doctor. So domain is X and range is Y. So basically, how do we find the domain and range for this graph? Well, we could find it by basically, I'll just do this little sample with y'all. And then right now, this is gonna look super weird. It's gonna look, what? I don't get it. But when you see it happening multiple times, then you'll understand. So basically, how I'd find my domain is going, see where this dot starts at, and what's the other one? And that would be at around 1-ish. Since I don't want to do decimals right now, we'll just assume it's 1-ish. So that's domain right here. All right, so it's at 1-ish. Then here, the ending point where it ends with, that's around 2.5. So I would write my domain as 1. I'm just rounding 0.75 to 1. And you need to notice if it's closed, dot is closed or not. Since this is closed, as remember, that would mean greater than and equal to. So I'll just put this greater than equal to X. And the second dot is closed as well, so I put greater than equal to 2, since I'm just rounding it. So that's how you find your domain. You just go upwards and see where it hits. Then for range, you do the same, but X. So I would see that, it starts, okay, I'll use a different color. It starts around 1 or 1.25, and it ends at 4. Then I would write my range as range equals 1 greater than equal to, since the dots are closed, right, for 2 of them, so it would just go closed. Then Y, since range is our Y values, and then less than or equal to 4. So that was our answer for continuous, domain, and range. So I have another continuous practice problem because, as I mentioned earlier, it's easier to find discrete, so I just want to do more practice problems for continuous. So now, instead of that U-shaped graph, we have a line. And this line has a closed dot and an open dot. And remember, it's very important because a closed dot represents it represents equal to. So suppose like less than or greater to, it would also mean like equal to. So less than or equal to or greater than equal to. This represents equal to. Whereas this doesn't represent equal to. This either means greater than or less than. So that's the difference between a closed dot and open dot, and that's why your teachers are probably like, remember to see if it's a closed or open dot. But anyway, I'm going to be literally doing the same thing for domain and range. So our domain and range. So I'm going to read, right? So domain, what we do is we see where it starts vertically. So it starts 1. And it starts here at 3. So our domain will be 1 less than, and it's a closed dot, so that would be less than or equal to X, since it's domain. then it would be only less than and not equal to, since it's an open dot, and then you would write 3. Then for range, you will go this way, horizontally. So do this in a different color once again. Domain 1 here, and 3 over here. So my range would be 1 less than or equal to y, because y is range, less than to 3. So basically, domain and range for continuous graphs at least, if you want to find the domain in this way, then you just go vertically. You see where one point starts at and where the other point ends at. Then for range, you literally go just horizontally and you see where it begins at and where it ends at. So that's how domain and range works.